Hello. In this video, we're going to talk about two ES6 syntax options called destructuring and spreading. So destructuring is a way of letting us do multiple assignment as a shortcut. So this is a syntactic shortcut. It's not required to write JavaScript code, but it is a way of writing JavaScript code more efficiently. So the basic idea is that if I had an array, right? If I have an array, I can assign each of those values to three different variables as 3 lines of code, right? I can say that X is going to get 1, Y is going to get the 2, and Z is going to get the 3. And really, I would write this as like my array index 0. This would be my array index 1, my array index 2, right? I can write that line of code. That's fine. Instead of trying to assign all these array values to these three individual variables, sort of one at a time as one line of code, destructuring lets me do that all in a single line of code. And the way that we're going to do that is we're going to say, I want to assign values to X, Y, and Z, right? So when it comes out, so what I'm going to do instead is say, I want to assign values to X, Y, and Z. So I'm going to write those three values inside of brackets on the left-hand side of the equation. I'm then going to say I want to assign something to those three values, and where I want to get the values to assign to X, Y, and Z are going to come from my array. So if I assign my array to the values of X, Y, and Z, this produces what's called destructuring, where the 0th element is going to get assigned to X, the 1th element gets assigned to Y, and the 2th element gets assigned to Z. So the elements from the array get assigned in order to the variables that I've defined here in order. And then again, now these are just variables, and they work exactly like every other variables. I can console log and log them out, and everything works exactly as expected. So this is a syntactic shortcut that lets us say, take an array and assign that array to lots of different variables all at the same time. Cool. So a couple of things to note, and I'm going to sort of demo this in just in the REPL developer console. So if I go ahead and let's make my array here. So I got my array. If I try destructured, right? We'll do it in here. I'm going to log out the X, the Y, and the Z so we can see what they all look like. All right. So if I refresh them out, right, my X, actually, let's do X. Sorry, I'm going to try to make sure we can do it in a way that we can read it. Z. Apologize, I didn't have this done ahead of time. All right. So, right, normally my 1 gets assigned to X, my 2 gets assigned to my Y, my 3 gets assigned to Z. If I reorder these, right, if I say do them X, Z, Y, the 1 will get assigned to X, the 2 gets assigned to the Z, right, because it's second, and the 3 gets assigned to the Y, right? The 3 gets assigned to the Y. If I have extra variables here, A, right, we're going to throw an A at the end, right? A gets to find a value of undefined, right? 1 goes to X, 2 goes to Y, 3 goes to Z. Nothing, but there's no value here, goes to A. So we can assign my array to more variables than exist, and we can say, here's more variables, assign the array to them, and if there aren't enough values, those variables just become undefined, nothing shows to them. If my array has 4 elements inside of it, and I try to assign them to only 3 variables, it all still works. It's just the 4 doesn't get assigned to anybody, right? The 1 goes to the X, the 2 goes to the Y, the 3 goes to the Z, and then I'm done. So any other values here, a 4, a 5, a 6, those get ignored, right? Those just, nothing happens to them. They don't get assigned to any values. Yeah. We can do the same thing for destructuring objects. So I can take an object and take all the values from the object and assign them to individual variables. Now, when we're destructuring objects, we're going to write out the variables we want to assign them to, not inside of square brackets like we do with arrays, but inside of curly braces. So destructuring an array and destructuring an object have different syntaxes, even though they do the same kind of effect. So again, when I now have my object that I want to destructure, array, I'll put in the object, I'll just copy it out, this will be faster. So in this case, the A for my object will go to the A variable, the B for my object goes to the B variable, and the C for my object goes to the C variable, right? So 1 goes to A, 2 to B, 3 to C. It's like it's more, again, gives us the same values 1, 2, and 3. Now, when we're destructuring objects, the variables aren't assigned in order like they are with an array, right? With an array, it was the first element goes to the first variable, second to second, third to third. Objects are unordered. There's no order associated with an object. So what happens here is that the keys in the object are linked to whatever the variable is that we're trying to define. So if this key is A, that's going to go to the A variable. If this key is B, that goes to the B variable. And if this key is C, that goes to the C variable. Which means if I change the order of these, right? If I say, let's assign to C, A, then C, then B, I still get the exact same result because A goes to A, B goes to B, and C goes to C. If I try to create a D value here, right? D is 4. Then again, the D doesn't get assigned to anything. There's nothing there. If I tried to have a D and an F here, or I've tried to have a D here, let's add in the D, right? And I'll delete that from my object. So if I try to say assign some value for my object into D, again, D is going to get undefined because there is no key in my object that's related to D. And it's not just the ordering here again. If there was no thing that related to A, then A would become undefined as well. It's not, there's no order to objects. It's just literally mapping the A to the A, the B to the B, the C to the C, the D to the D. These keys have to match identically, right? If I use a capital C here, then my C is undefined because the capital C is a different variable than a lowercase c, right? If I try to map dog is 4, and this is going to try to be to husky, right? Those two things will not map to each other, right? If I try to say, what is husky? Husky doesn't get a value. So the idea is that a key maps directly to the variable. Destructuring objects is a way for us to be able to get values out, get a lot of values out of an object and get them as local variables. So we don't have to refer to object.a, object.b, object.c. I can just refer to a, b, and c, right? Instead of talking about my object.a, I can just refer to the a variable inside of it. Okay. So again, here's a chance for you to check your understanding and make sure you're okay with the syntax. So you're welcome to pause the video and give this a shot on your own. And once you remember how you think about an answer, then hit resume and you can see how it works. All right. So the question is, which statement will assign a value of 3 to the variable C? And the correct answer is D here. That will work correctly. With A, our syntax is incorrect. We need to, in order to do multiple assignment, we need to put the brackets on the left-hand side of the equation. This is considered invalid syntax. You can't put you can't just say make a variable A, comma, something else. You have to indicate what kind of destructuring you're going to be doing. With B, you have to make sure that they match, right? This, because I'm using square brackets here, this is for array destructuring. I can't assign an object to an array destructuring. C, this is syntactically correct. It'll all work as expected. It's just that there's no C here, so the variable 3 won't get assigned to a C variable because I just didn't declare a C variable to assign to. D will work fine, right? This is again array declaration that works, destructuring that works great. E, you have to make sure you're assigning an array to these 3 values. Unlike in Python, for example, you can't just take tuples and sort of ignore any kind of bracketing around it. You have to indicate that I'm taking an array of these 3 things and assigning them 3 variables. You can't just say take 3 things and assign them 3 variables. You have to make an array, and we are destructuring that array into these variables. Okay. So destructuring can be useful as a way of, again, it's a syntactic shortcut. It's a way of letting us be able to sort of refer to things quickly. The other place that destructuring shows up, actually, in kind of an interesting, useful way, is that we can do destructuring inside of function parameters. So this is commonly used inside of React because React has a lot of objects that come in as parameters to functions, but it can potentially make code maintenance a little bit harder, a little bit awkward, so the thing we need to deal with. All right, so imagine a function here. So a function here takes an object, a person object, right? So an object as an argument, it has one argument, and that argument is an object type. And then it accesses the height and the weight of that person object. This should be person object, for typo. And then it does some math to get their BMI or some other useless metric. We can paste in the person, and that gets passed in. Now, because this is a function, right? What's happening when I call it, right? When I take a person here and I pass into this function, what's kind of implicitly going on, kind of like behind the scenes, is that value, right, this person value here is being assigned to this person object argument variable so that I can then use it later. So implicitly what's going on here is I've said take this object value and assign it to this variable. Now, here's an object being assigned to a variable. We just learned that we can do destructuring on that. So we could imagine taking this line of code here and rewriting it to say, let's take this object, and instead of assigning it to a single variable, person object, let's assign values from that object into two variables. Let's assign the height to the height and the weight to the weight. The name will get lost, and that's okay, but really I only cared about those two values. So effectively what we're doing here is we're saying, because person object can be assigned to this, we can do the same thing by saying have that exact same thing get assigned to this destructured set of variables. Notice that we've just replaced the word person object with this destructured set of variables. So we're actually allowed to do that in the code syntax itself. In the function declaration, right, where we're declaring the function arguments, we can actually put the destructuring assignment, right, the curly braces that say, what are the two values you're going to get? So effectively what we've done is we sort of made the shortcut here where we took our get BMI that took in a person object. And you can imagine that we then would say, let's do our height and weight to be equal to this person object. All right, let's do some destructuring that lets me be able to easily access it. What I'm allowed to do is skip this assignment middle step and just go ahead and put this piece directly inside of my object, my function declaration. And that will now do the destructuring. This function still takes one argument, a single argument that is an object. It's just that object is going to get immediately destructured into its parameter parts when the function's called. So we're basically skipping the middle step of doing this work, right? This thing is getting skipped by letting us sort of do it immediately directly inside the function argument itself. So this is a syntactic shortcut. That's all it's doing, right? It's not required, but it does a way of writing things faster. At the time of this recording, I go back and forth on how much I like this or not. So if you look at this function declaration, that looks fine, except it's really, really easy to misunderstand the arguments this function takes. If you're glancing at this and you're not looking carefully, this function looks like it takes two arguments. It looks like it should expect a height and a weight. I would expect to call get BMI and pass in like a height and a weight and expect something to happen. But that's not how this works. It doesn't take in two arguments. It takes in one. That one is an object, and you can only see that by looking at this curly braces. And I know they're sort of commented out because it's you can't see they're sort of faded out, but that's the thing that becomes hard to miss. So in that sense, I don't really like this syntax because it makes it hard to know how to call the function, because the function says like, well, wait, how many arguments am I supposed to give it? It masks that, right? It's hard to see. That said, if this just says person object, that doesn't necessarily tell me about what that person object should look like, right? Does that person have a name, a first name, a last name, and an address? Does that person object have like a first name, a last name, a shoe size? Does that person object have a course listing for what courses they take? It doesn't tell me what values or what properties should be in that object. Versus if I do this explicit destructuring syntax, that tells me I'm taking in an object that should have a height and a weight. And that means it could be a person, it could be a duck, it could be a dog, it doesn't matter. But if you give me a height and a weight, I can work with that. And so that lets us, the function sort of declaration, have more information about what kind of object gets passed in, but it's hard to tell that it's an object that is getting passed in. So there's trade-offs, right? Sometimes, in some ways it's easier, it tells you more information, but it's also a bit harder to read that information along the way. So it kind of goes back and forth, and you'll see us work both ways sort of throughout the rest of the class. You will see this syntax used a lot in React by people who are trying to save every possible line of code for some unexplainable reason. But so again, as you're looking at function arguments, keep an eye out, be very carefully looking for those curly braces, which is going to indicate that it's taking in an object that's getting structured, not multiple arguments. Okay. So yeah, again, we now have two additional ways of writing function arguments, right? We have two different ways of writing the syntax. They do the syntax, but they do the exact same work, right? We can take in the object directly and then just access its properties as we want, or destructure it all inside the function, or we can do the destructuring along the way. Again, there's trade-offs either way. Pick which one you want to use and just be consistent. Watch out for trickiness of moving one way or the other. The second feature, syntax feature we want to talk about in this video is the spread operator. So the spread operator, it's also referred to as the rest operator, but technically it's called the spread operator. And it's written as 3 dots. It's an ellipsis. And you write those 3 dots. It's a unary operator, so you write it immediately in front of another variable. So the same way that if you had a value x and you want to make a negative, a negative value or a negative number, right? You just put the negative in front of that value. You use the dots in the same way. So we would say use a spread operator by putting 3 dots in front of an array, because we use them with arrays or with objects. What the 3 dots do, what the spread operator does, is it lets you reference the elements of an array or of an object, right? All the stuff inside of it. So it doesn't refer to the object itself. It refers to kind of collectively the stuff inside of it. That's really the best way I can think of actually explaining what's going on here. So the way this is particularly useful when you want to try to make brand new arrays or sort of extensive arrays by taking old arrays and adding on bits of content to them. So for example, let's take an original array here. Oh, right. There's my original array. It has A, B, C, and D. What I can do is I can create a brand new array by saying, take all the values from the original array. Again, think of the 3 dots as meaning elements of. So this is the elements of original array, A, B, C, and D, and put them, those 4 things, inside of new array. It's almost like a copy and paste operation. It's like literally saying, I'm making a new array. I want to copy and paste all this stuff and put it right here. And that's what we're going to do. So if I make this new array, right, that has the values of the original array with E and F after them, then if I then say, what does new array look like? Right, it has the values of old array, A, B, C, and D, as well as the E and the F along with it. So what this is letting us do is it's letting us make a brand new array that has the old array values inside of it as well. This is particularly great for if you're trying to duplicate an array or if you're trying to make sort of a new expanded array. So for example, if I have some data that's an array that has some stuff inside of it, right, I can say make some new data that might be all the data stuff from my old data plus a new object, right? So if this has a bunch of objects inside of it, then I can make some new data that's got my old data plus a new object inside of it. I can make a copy of the data, right, by making an array that has all the original data values of the data in it. So this says, make me a new array that has all the same values inside of it, but it is technically a different array. So I now have 2 different arrays that I can work with. This becomes particularly useful in that kind of regard. You can use the spread operator with objects as well. It's actually a little bit more, in some ways, it's more common to use it with objects. Well, actually, it's about the same. So with an object, right, again, I can have a person, an object. I can make a copy by saying, make me a brand new object. So again, I'm writing an object literal, right, curly braces, but instead of having to literally type out name is Ada, height is 64, weight is 135 again, I can just say, use all of those values, both the key and the value pairs, from that person, and that's what's going to go inside my new object. So these objects will have the same properties with the same values, right? They'll both be named Ada, they both have the same height, they both have the same weight, but they are different objects. They're different values. If I modify one, it won't modify the other. They're 2 separately pieces of 2 different objects. This also allows us to spread objects into sort of new pieces. So for example, as I said, we can create if I want to make a person with a hat, I could say make a new object that has the hat bowler property as well as the person's property along the way, and that now gives me a person with a hat. All right. The one other trick out of this that I want to sort of show you how that works. So if I have my person, we're going to log out my person with hat. Oh, no, there's my person. I want my person with hat. Sorry, I got to copy this code into the piece. All right. So this is going to create my person with that. This will be, this is going to be person 2. Person 2 is a terrible name. Person copy. Person copy. All right. So in this case, person copy, we're adding a hat to all the data from my original person. So you can see that I now get my new person copy has the hat, name, height, and weight. Interesting things to note. If I say give this person a different name, how about we're going to name this person Ada, or how about name Dad, right? Ada backwards kind of thing. Sure. What this is saying to do is, like, the effect of this means is that my person copy will now have the, save this, right? You'll notice that this had no effect, right? I said give the name of Dad, and then it gives me all the values of person. So effectively what that meant, that what I was doing is it's almost like I copy and pasted, right? Instead of all the values of person, I just put in the values of person, which means I now given this thing a name property twice. And if you try to declare a name property twice, the second value will win, right? Ada beats out Dad or replaces it, so it ends up getting, because you can only have one property of each name inside an object. If I put this in the back, right, if I said, let's take my person and then let's make it the same person, but whose name is Dad, now their name is Dad instead of Ada. Because what's happened is that now it's like I had written out name, height, weight right here, but now the second name, the Dad, is the one that replaces that. So this can be a really useful way of saying take an object and like just modify one property or modify a couple of properties without having to actually assign to them individually. You can just say, make me a new object that has all the old values, but these other ones shifted or rearranged or changed. Okay. And so that's going to let us spread. So again, the spreading operator is mostly useful for doing things like making copies of objects, which we need to do is we're trying to build out more complex software systems to make sure that we don't end up having like sort of bad referencing going on. We'll often find ourselves making copies of objects. It helps make sort of functions more pure, and let's be able to do some better functional programming work. And it can be really useful as a way of adding in elements to existing arrays at the beginning or the middle in different ways without having to use push or pull or anything like that. Great. Yeah, so that's destructuring and spread. These are sort of two ways. Again, they're syntactic shortcuts. They're not required for doing any kind of work, but they are ways of writing code faster, and we'll see these used as we write more advanced JavaScript work.